your warm-up today is, if evolution does happen, and according to the evidence it does, there must be some pieces of evidence that support it. Ones we went over on page 46 in your interactive notebook. What types of evidence could a scientist use, or what types of evidence could you use in a discussion to show that we believe this has happened? You want to start? All right, so you guys want to be on page 50 in your interactive notebook. Your essential question is, how does evolution influence discrete traits versus polygenic traits? And then your topic is types of evolution. Aramis, you had your hand up.
I was just wondering if that was an answer.
Yeah, it's first. I'm just bad with penmanship, that's all. So, ready to move on? All right, we'll do it then. So first thing that's going to pop up is a picture of stuff you recognize. Don't write stuff down yet, but do you recognize the picture? All right, it is two bears. Very good. So, next question. Same type of bear, different bear?
Same type of bear. No, that one's black. It's still black. One's black and one's brown.
Angela says they're both bears, so we're going to go with that. And in fact, this is somewhat confusing, and it's kind of unique to the western states. It doesn't happen where I'm from in Maine. But those are both the same type of bear. Even though one is brown, it's actually a black bear. Confusing. I know, because it's brown, so it should be a brown bear. But there are two different types of colors. They're called color phases here in Oregon of bears. There's black bears, and there's brown black bears here in Oregon. So there's two different color phases. And pretty much the dividing line for these is like Central Oregon-ish. On the Coast Range, you tend to get black bears. Once you go east of that, you end up with brown black bears predominantly. There's still brown ones on the Coast Range. There's still black ones out east. But there are different colors of bears. Even though they're the same species, there are different colors. So hold on, Aiden. Why would it be that the east side of the state would be populated by mostly brown-colored black bears, and the west side of the state would be populated by mostly black-colored black bears? Is it interesting?
Because black tends to attract more of the sunlight, so on the west side, that's why you find black bears on the west side of the state. On the east side of the state, it's hotter, so this prefers black bears, so it doesn't attract as much.
That could be a reason, like thermoregulation. So the black on the east, if they were black on the east side, they would be getting really hot in the summer, and that could cause an issue for it. There might also be some different reasons, Miss Kitty.
Maybe they could camouflage, beneath their surroundings.
Yeah, if you've been to the east side of Oregon, like she mentioned, in the summer it's browned up. There's not much rain out there, and it's kind of deserty. And there could be an advantage to being brown, right? Not that they get preyed upon, but they're predators, and it could give them an advantage. On the east side, or the west side, where we're at, might it be advantageous to have dark colors, like a black color instead of a brown color?
The forest.
What about the forest here?
It's really dense and deep green. It's really green and dense. And when the green gets together, it's really dense and looks black.
Okay, yeah, lots of shadows, lots of dark areas, especially if you've ever, I don't know if you've gone to the coast and hunted Roosevelt elk, or tried to get after a black bear on the coast, or even been in the coastal forest. It's dark, it's dense, there's lots of shadows. That color actually blends in pretty well. They're big, tall trees with a big, heavy canopy and not a lot of light makes it down. And the result is perhaps these things blend in a little better. So we'll talk about that after I answer it. Well, we're going to talk about this, then I'll get to your question. So what we're looking at there is a discrete trait, right? Either you have black hair or you have brown hair. So it's not polygenic. It's either one or the other. And with that, what we find is that with evolution, the favorable trait is more likely to survive and reproduce, like it says here. It's called survival of the fittest. The one that fits in the best has the highest population. The one that doesn't fit in as well has a lower population number. So if you look at on the west coast, we'd have high black coat color populations and a low brown coat color population. If you go to the east side, that flips. It's high brown coat colors, low for black coat color populations on that side. And that's because in discrete traits, there's only two options. One can be good and one can be bad. One population goes up and one population goes down because there are only two phenotypes. Aiden?
Why are brown bears way bigger than they have smaller stones?
Are you thinking of grizzly bears?
Oh shoot, yeah.
Yeah, grizzly bears are a different species altogether. They're way bigger, way more aggressive. Black bears tend not to want to deal with humans. Like, if they do come in contact with one by accident, they'll usually get out of there. Grizzly bears a little bit different. They want to avoid us too, but in a confrontation, sometimes they'll attack. They are the most aggressive of all the bears. That's the ones you really want to see. So, moving down here, we're going to go into polygenic traits. So you remember what kind of curve this is called?
Bell-shaped.
Very good. Yeah, bell-shaped curve. And that is how polygenic traits are distributed. We've got, if we want to use height for an example, and we're looking at the area that's kind of greenish, we've got most people are average height, and the further you get from average this way, the shorter you're getting, and there just aren't a lot of super shorties, and there aren't a lot of super tallies like that. Most people tend to be average. So what we're looking at here is how evolution works on polygenic traits, which is a little different than with discrete traits. With discrete traits, one thing goes up and the other goes down. Black coat color goes up, brown coat color goes down, and vice versa. With polygenic traits, there isn't like only tall people or only short people. Right, Juliana? Can you be writing this down and paying attention and not doing whatever we're looking back there? So, with polygenic traits, you're not either tall or short. You're kind of short, a little bit short, a little bit tall, a little bit, you know what I mean? There's like the blend. So it doesn't work. Like only tall people survive or only short people survive. There's like a blend. So what I'm going to ask you to do here is consider this any polygenic trait you want. It can be height, it could be speed, it could be intelligence, foot size, whatever. Come up with a polygenic trait you can put on the x-axis here. And then explain to me an event that would cause this shift to happen. This dashed line represents the original population, and some event occurred that pushed this so the animals moved to the right on this graph. So if you want to consider the speed on here, something occurred that eliminated the slower animals and as a result made the population faster. The average speed increased. So with your group at your table, and Peyton, since you're kind of at your own spot there, you can work with the group. One of the tables that's right around you. Come up with an event that could cause this to happen. A population with a polygenic trait to move either one way or the other on this graph. I'll give you guys about 3 minutes to come up with one. So on average, the result here is the population gets faster because of the events that you guys mentioned. It could be height, maybe only tall people are able to, or tall animals that can't climb trees or use ladders are able to reach things, and as a result, the average height gets faster. It could be that there's a predator introduced, and it can catch the slow animals, but it can't catch the fast ones, so the population gets faster. That works just fine. Next up, then, is to write down the actual definition. It's called directional selection, and the actual definition, as it's read here, says that individuals at one end, so not both ends, only one end of the original curve, so we're talking this end of the curve out here, have a higher fitness than those in the middle, or the other end. So higher fitness means they're more likely to survive and they're more likely to reproduce, is what higher fitness means. So the next one we got here that you guys have to have is this graph. So we're looking at a graph, and this graph shows what's considered to be stabilizing selection. So in this one, right, the idea is we're going to come up with a scenario again that can explain this. Again, a polygenic trait on the x-axis down here, and you want to describe something where it's bad to have maybe too little of it or not enough over here, and it's bad to have too much, but it's good for you to have just the right amount. So something where it's too much is bad, too little is bad, but the right amount, like in the middle, is perfect to have. So describe an event that could result in this type of selection. Like if you want to do speed, something that could wipe out the slow stuff and wipe out the fast stuff and result in like just a medium speed thing. So that's your plan here. I'll give you 2 more minutes to handle that. And the definition you want down for a stabilizing selection is this. And you guys described it as I went around and listened to you describe to me your scenario, was that the people or the individuals or the animals at the center of the curve have a lot of fitness for whatever reason. It could be because of size, like they're not too small, they're not too big. It could be because of like speed. Somebody said you don't want to be too slow because then you stand out from a crowd if you're in like, you know how fish will form those huge schools of fish, and that's their way to not get eaten because the predator gets confused. If you're too slow, you stand out because you're moving slow and you're not part of the group. Or if you're too fast, you stand out because you're moving too fast. And so being just the right speed for a fish is kind of the same deal there, same idea. So now we've got two down. We've got directional and we've got stabilizing. And then there's the next one, the last one we've got, which is called disruptive selection. So here's a look at the graph for disruptive selection. I'm going to have you do the same thing. The dotted line is the original graph. What could be an event that causes this distribution, where the low end and the high end of the graph go up, but the average, what used to be the average, goes down? So what event could cause disruptive selection? That's because nobody turns to anyone to do, and I want to make sure you understand. So when I get that.
Really suck. I haven't had a day to do it.
It's because in the syllabus it says it's always due the very next day. You all signed off that you did, so I certainly hope that you did. Don't sign stuff you don't read. Have a nice day, stuff. You too, Mr. St. Clair. Oh, thank you.